Welcome to our fall incarnation of the second Saturday 4D PNR layout tour. My name is Lee Marsh, and I'm a co-host with Burr Stewart on the layout tours here. Today, I'd like to welcome Kevin Wills, who is building a very nice in-scale layout in the local Seattle area here, the Covington, Kent area. And Kevin is one of those guys that's developing a mainline model railroad, so running some big prototype trains. And I think you'll really enjoy this layout. So with that, I will turn the floor over to Kevin.
Yeah, I'm Kevin Wills. I have a layout in my basement in Auburn, Washington here, in scale. I chose in scale because I could get more in a given space. I grew up doing HO. This is Sierra Foothills, so it's a freelanced in scale layout set in the 80s and 90s. I grew up near the Santa Fe tracks in Central California and the Southern Pacific as well. So I like that motive power, so I chose that time frame, but that's about the only reason I did. So since I wanted mountain railroad, I want some stuff by the water, etc. I said it's going to go from the Central Valley, Concord, up through the Sierra Nevadas and end up on the other side in Bodie, which, it's a big train hub, Bodie over there, as you know. And going from there, let's see. So here I have a station diagram, and each of these points represents a control point on the layout where there's a signal and turnout control. The colored dots represent points where there are switching potentially going on. And the main yard, I have one main yard for Le Grand, which is my hometown. And you have to traverse pretty much the entire benchwork of the layout to get there, half the layout to get there from staging. And I also have a branch line that goes off from Oakhurst over to Bagby. It has some exchange tracks in Oakhurst, and it goes over to Bagby. And Stockport, which is a port switching area, it's really kind of a branch line too, because it has its own set of exchange tracks that goes over to the port itself. I started this layout just a little over 6 years ago, just broke ground. And what I broke ground with was starting my first turnout on fast tracks, because all my turnouts are handmade using fast tracks jigs, which I don't have a picture of. But I was learning to solder and build a turnout on fast tracks at the same time. I'd never soldered. So the first turnout took me 9.5 hours to build. After the last one, 166 of them, I got it down to about an hour and a half. So it was quite a learning curve over time. The layout has a pretty long main line with 8 passing sidings, and it takes just under an hour to run the whole main line loop at scale speed. Another thing I have some 3D CAD, 3D printed tunnel portals, piers, abutments, and car card boxes. So that's another skill I picked up along the route, was learning how to do 3D CAD and 3D printing. And we'll touch on that a little bit. And then I have some touch toggle control panels. For you electrical guys, there's 3 power districts here with 13 sub-districts. And we're fully signaled on the main line with a hardware USNS CTC dispatcher panel. And if you guys got questions while I'm going through this, just jump in with a question, because we'll probably go through things pretty fast. Right here, I spent about a year thinking about this using Third Planet track planning software. And so I got some screenshots from that. Now the layout the track plan isn't exactly as you see here, but the bench work is, because I use it to lay it out so I can get the most efficient use of the space in the room. So what you have is 3 levels here, and this is the main level, and then you have staging below over here, which is the lowest level. Then you have an upper level, which follows the same pattern, which is basically a return loop. You have total of 5 helixes. 3 of them are right here in one structure, and 2 of them are an embedded helix. And then you have, so here's your Le Grand, your main switching yard. And then you have different areas you can switch at Boot Jack, Coarsegold. And most of these towns along here are real places in the Sierra Nevada that you might be familiar with, but in no way would none of them have been connected like this, especially by railroad. So it's just towns that I'm familiar with that I grew up near. And we said we have like I said, Bagby, we have exchange tracks, and that goes over here to Bagby, which is not shown. And then your Stockport, which is fairly accurate to what you see here, the exchange tracks on the other side of the deck right here, for that's kind of a branch line as well. And then I intentionally had the main line go across the workbench right here, because even though I don't have a picture of it, right here on the fascia, I have a plug-in, so you can plug into everything on the layout. You have your main LocoNet bus, you have the accessory LocoNet bus, you have track power, you have programming track power. You have 12-volt power. It's just basically so you can program locomotives, electronics, everything at the bench as much as possible and test it before installing in the layout, where you don't have to be in some weird contorted position in the layout trying to do stuff. So you can do most of it from the workbench. So this is, like I said, this is the main deck, and the staging's below, and then the upper deck is right here. And they're all connected by these helixes. Okay, and then going on to actually see the layout right here. So here's one view of the staging yard down here. And then here's the west part of Le Grand, the main yard. And then up here is the upper part going into a siding. So if you turn your head right, you'll see the other half of all this. And the staging yard is double-ended, so it connects. So you can have a loop to run the trains and just keep it in a show loop right there. And so you have East Le Grand and Bear Valley and Knowles. And then here is the main yard, and that consists of 4 arrival departure tracks, 6 classification, 1 engine service facility, 2 passenger tracks, and 9 industries. Now, we've made strides on landscaping. We have a long way to go. So what you see here is what you got so far, although we're working on it. Here is the engine service facility. So you have your standard Walters kits, I think. You have your 6-stall roundhouse, your diesel service facility, and your car shop. And over here, you'll have a sanding and then diesel tanks for fueling up the engines. We don't have any steam power on here. I mean, we could. It wouldn't be era specific, but it's just kind of hard to run on these long main lines and with the grades and the helixes. So I haven't tried a steam engine. I should assume it would work. But, and then we have the touch toggle control panels, which I'll go over in a second. Here's the staging. It's a double-ended staging yard with a double crossover coming in here, which you can't see. And you have a wraparound track, which you saw in a previous slide. So you can come in on either track from either direction, and you can send trains right back out in either direction. So it's just, I did it for maximum operational flexibility. And then we have the car cards, and all the staging can be controlled from this control panel here, and it's all route controlled. So you just press one button and it sets all the turnouts to enter or exit from that track. But in practice so far, what little practice there's been, we control everything from the JMRI, the computer control panel. It's a lot easier, and it saves people from gathering around this point and cluttering things up. So here is the main helix, which consists of 3 separate helixes here. Originally, the layout was going to be once around each of the main deck and the upper deck. And then I had an epiphany one morning. I woke up and said, if I just replace this loop right here in this main helix, I can go around both the main and upper decks twice and extend my main line to be twice as long as it originally was. And for the same price, you're building the bench work anyway. So that's what this does. And like I said, there's 3 helixes separate here because you got 2 tracks coming out of staging, and then you got your main, and then your upper deck, and then one helix connects between the 2 decks. So this was a challenge build. I never built a helix. I'd hardly ever even seen a helix. So touch toggle control panels. I don't know if you're familiar with touch toggles. All the switches are electrically controlled, and on the fascia, they're controlled from the panels here. And it consists of a picture frame with a plexiglass screen. The touch toggles are mounted on behind it with user-generated graphic on the front, whatever you want. This is a customized turntable control panel that I designed and made. But here's the touch toggles, and you can see how you kind of put it together. So these are the touch toggles. They all wire into a controller, which goes into the rest of your layout. So I just thought it made things much more sleek and interesting. I wanted to keep the decks as clear as the aisleways as clear as possible. And so these pivot on a cedar chest friction hinge right here, so you can move them in and out as you see fit, but you can push them in so people aren't bumping into them. And 3D CAD printing. So I've learned to 3D CAD and 3D print. Originally, I drew these piers up right here by hand, and Chuck Lee was gracious enough to CAD them and print them for me. And when they came out so amazingly like the drawing I had, I said, I got to learn that skill. So I did, and I think almost all of the abutments, piers and tunnel portals here are 3D CAD and printed. That way I can customize and make whatever I want very quickly, and you can iterate and change them up and all that. So, and then remake them. So, and then I also did the car card holders were the same type of thing where I wanted to keep the aisleways clear, and I wanted to be able to make a bunch of them fast. So I had to make at least 58 boxes. So I catted a box right here that's canted down, I think about 9 degrees. And I made them in sets of either you can print them either sets of 1, 2, or 3, so you can combine them to make any number you want. And you just have to do a different face. And then you glue the boxes to the face, and then you stick them underneath the fascia right here. So it's all flush out here. And then you can remove them if necessary. The one for the main yard for the classification and arrival departure tracks have magnets behind them, so you can take these little guys right here with your destination and put them on the magnets and move them around however you'd like. And the magnets were 3D printed as well, with a magnet embedded in each of these and then spray painted. So just moving around the layout here is, if you guys are familiar with the Yosemite Valley Railroad, Jack Burgess has done that. I've known him for a while. So I grew up near this place right here, where they used to be the Barrett Bridge. The Yosemite Valley Railroad used to cross Lake McClure in California. I wanted to recreate that kind of. So I did it with the space I had as much as possible with the piers. I had to, I hit up the Merced Irrigation District to give me some drawings of the piers, but it's from 1925. They sent me what they had, and the only dimension I had was this very top plan view of this pier right here. And I had to scale everything else off of drawings and what I found in the literature and draw it up by hand. And it came out fairly accurate. Now, the bridge was demolitioned in the 1960s and floated off for scrapping, but one piece didn't make it. And so it's still there when the lake is low. So we're paying homage to the bridge both then and now. So it's kind of a mixture. And you can see it from right here too, what's left of it when the water's low. And just moving along the main line, going around from the Barrett Bridge to Willie's Gulch, which is just a couple of bridges. You've got your obligatory microengineering bridge you see on a lot of layouts right here. And then this one spans such a great distance, I had to 3D print that girder bridge and piers and everything to make it span this distance. So, and then going around the layout, have mostly completed the upper deck, and I'll go into that a little later. But the lower deck still needs scenery, and we're in the process of building a ton of buildings right now, and it's trying to perfect some other scenery techniques, roads, et cetera, off layout. And you can see some of the signals here in operation. So we got coarse gold, boot jack. Now, although we go around each deck twice, in most places I tried to separate the main line with elevation. So if you're down here, this is basically on the other side of the layout up here. It's take you about a half hour to get from here to here if you're going around. So I try to do that where I could. And you can see looking down here, we have Wani and coarse gold. And right here is the embedded helix. And since it's embedded, you can't see it at present. And then the short line Bagby right here, and had to build a lot of the buildings ahead of time just so I could lay the track work out. And you have your Stockport exchange tracks because the port is on the other side of this divider right here. And then here is the port, and we have a container ship and a ton of switching here, about 12 industries and a lot of switching in here. I don't think anybody's actually done switching here yet, but there's going to be a lot of cars that fit in there. And we have a lift bridge crossing a little river that leads into the bay right here. It doesn't actually lift, but people want me to do that, but it just wasn't worth it because it would take too much time to figure all that out. Here's the embedded helix taken from various angles. It was a lot of bench work. I'll show you later if we get the construction photos to fit this in here. It's just a double track helix. All my helixes use Kato track because it's already the right radius, and it's super elevated. It's easy to put in and remove. And we put little foam core strips that we sanded down to the right angles and just glued those down. So the track itself isn't glued to the helix. We just put these foam core things, so you just pop them off the screwdriver and you can remove the track, or if you need to for whatever reason, which is a good thing because when I built that first big helix, I had to remove the take half of it apart to put in that different loop so I could get twice around each deck. Here's just some looks around the upper deck. The upper deck, there's no switching whatsoever, but there are 3 passing sidings, but the dispatcher in most cases will operate those and you'll just be watching, but you're able to operate everything from the fascia if you need to, if you would like to. Some more looks around here and you can see the some of the signals in play right there.
Kevin?
Yes.
At some point, would you talk a little bit about your lighting?
The signals or the lighting in the
overhead lights?
Oh, okay. Well, I can tell you about that now. They're just Costco LED lights. I replaced the fluorescents that were originally in the basement. I had to redo the whole basement, and they're just overhead there. I would prefer a valance and some probably LED lighting like I have on the lower deck. Do that for the upper deck, and maybe in the future I will, but right now that's not high on the priority list. On the middle deck, I have strips of fluorescent light underneath all of that to light that up because the shadow of the upper deck.
Thank you.
And here's just a sample, and I had to make these boxes to put the electronics in the main room, and you can see breakers for the different power districts, block detection, stationary decoders, signalings. This is just a small sample of the wiring electronics underneath this thing. And we also have a internal phone system, PBX, so you can call the dispatcher. The dispatcher can call you. There's only 2 phones, but that's all you really need. It's not that huge of a room. But yeah, there's been a lot of wiring. So it's a good thing I learned to solder, isn't it? After all this, because everything's soldered under here. Okay, and then here is the CTC control panel. At first I did it on, of course, on JMRI on the computer. And then I didn't even know what one of these was when I started this. I didn't ever seen a CTC panel, didn't know what it was, didn't know what it did, how it worked, anything. Then I went over to Chuck Lee's and saw his, and he did a presentation probably about, I don't know, was it last year for you guys? And I saw it after the fact, and he showed you his very nice CTC panel, and he was much too modest in his accomplishment in building that and how he built it. There's a lot of work that goes into it, and he was very modest, and I didn't tell you, I don't think, enough about that, but he was gracious enough to share his board design, which underlies this whole thing, with me and give me advice. Now, that doesn't mean this thing was a cookie cutter that just went up. There was still a lot of engineering that went into this, and planning and sourcing of components, and then just sheer labor to build something like this. Now, since I didn't plan on having something like this when I designed this, I don't have a sit-down desk where this should be. So I had to fudge it in the only place I could in the basement, which is hanging it here on some supports, and it had to, this post goes through the middle of it. So there's a lot of structural design that goes into this. So I don't know if a lot of you are familiar with CTC panels and how they work, but the whole main line is controlled by the dispatcher. So at any given control point right here, which is where there's a turnout and signals, the dispatcher will control the direction of the turnout, the signal direction, giving the green light either direction or putting it at hold. We can lock the turnout from local control, so nobody can switch it locally, so they can't change the route underneath the train or once the route is set over it. We also have a maintain or call light button, which lights up a blue light on the panel and on the layout at each of these control points, indicating for the train crew to call the dispatcher. So that's, I think, somewhat prototypical. And again, Chuck did that, and so it works really well in his layout and operations. So I'm doing the same thing. And here's some of the signals. Now, I had all these built by Custom Signal Systems, I think, is the company, and they're all searchlight signals like I grew up with. And he built them. This one, my specific, this was a custom one, and the other ones I think he provides stock. But anyway, I ordered a lot of those and hooked them in because I wasn't going to spend time wiring up. They're all 3-color LEDs. Mm-hmm. And then some of the construction of this CTC panel was interesting. So here, like I said, these had to stack on top of each other and then had to go have a post go through the middle, but yet be structurally sound enough to not fall apart while you're building it. And then all of this had to be CAD'd, and I did it on CorelDRAW, which is essentially a version of CAD. All the artwork was done on there as well. And then I had to find a company to actually fabricate this stuff. Chuck did all this own fabrication, but he has all the equipment to do it. I did not and was not going to buy the equipment to do this. So this is all laser cut, standard, I think 16 gauge steel. And then all the aluminum here had to be anodized and then laser etched with the artwork. And that had to fit precisely over the steel panels that go behind it because the light and bezel had to go through each one. And the steel panel's back behind the artwork, so magnets will stick to the panel itself so you can keep track of your trains. And then here is the board that Chuck designed that goes behind the CTC panels, each of these spots, whether you're having just for a turnout control, or you're having or you have a control point where you have a turnout and signal control. And I had to modify some of these as well for my particular application. And there's a ton of other things you got to do. You have ricks. You can get these things at ricks, these to go on the front, but you have to paint and label them and sand them and et cetera. And you have to get all kinds of different hardware and screws, all the right size. And then I cannibalized Cat6 cable for all the wiring because you got 4 twisted pairs in each of those. And then you're using RR circuits, TC Mark IIs to interface with your LocoNet. And I have a separate LocoNet accessory bus for all signaling, turnout control, and block detection traffic because it's made things a lot easier. And it's been borne out because Chuck originally had his all on the same bus with his, the LocoNet bus with his locomotives, and he was having trouble having to reset his CTC panel during operation sessions because it would lock up or something like that. And he recently switched over to have a separate bus for each, and he's had no problems since then. So I think that says a lot that if you're going to do this, to have a separate LocoNet bus for this type of traffic. And then anybody want to see construction photos? I got a few of those. Okay, all right. I said we broke ground a little over 6 years ago. I'd never built anything remotely close to this. I had a little layout about 10 years ago in my first in-scale, and it was just a 9x3 little one level job. And this far exceeded our skill level to start out with, I'll tell you. So I started out on 3D Planet software, and here's some 3D views that you can see from that software package where I was planning how to lay this out in the room I had. It took about a year planning with different layouts in here before I settled. And then when I started building, we built something different anyway. I prototyped everything, bench height, L-girder construction, panels, everything was prototyped before we started really building right here, you can see. And then the main decks like this, all the big decks in here are built with moving in mind. So, because I anticipate moving at some point, I want to be able to take most of them with me. So that added a lot of construction challenges. So each of these, like this is a 13.5 foot long section. It has to, and for me, it had to be movable. So that presented some challenge with wiring and bench work. So it had to be stiff enough to move. And it might have been much easier to build it in place, believe me. So it was built, this and the staging yard were both built on the X-girders, freestanding, built and wired up and fully tested before they were installed on the wall, and then just plug the wires in because it was so much easier to do that. You can see right here, we have it tilted up because we're going to airbrush the tracks that color them right here. And let's see, this is me praying this is all going to work about 5-6 years ago. No, really, this is we were designed the helix. Okay, I never even touched a helix, and I didn't know anything about them. So started designing it. First used the software, and then figure it out. And some of you build helixes, the challenge. But one thing is I wanted the framing underneath that it sits on to all be within the helix. So the footprint of the helix is just the circle. So I came up with this little benchwork that goes under it, where the weight is borne on the wings of the benchwork, and the legs extend out from down here. That way you're not hitting your knee when you're getting around the helix. You can see it down here, or kicking the little 2x2 leg that's underneath it. It just made for a much better structure. And right here, we've cut a couple loops of the helix, and I'm testing the train, how much 2 engines or 1 engine will pull up this grade, because I had no idea before we went and built this helix. We want to figure, will the trains go up it, and then how much train will go up this, because we had no idea what we were doing. So, and again, this is me working on it, but kind of, looks like I'm praying that it'll work, and that kind of was, because I had no idea, because we already built half a room of stuff in this helix. If it didn't work, we were kind of out of business. And, in addition to computer modeling, we did like many model rooms would do. We laid it out with, I call it a crime scene tape. So we laid all this out on the floor to test if the aisleways were going to be adequate. I know within the standard 3 feet, and some people adhere to it or not. So we laid them out and walked around. So is this really going to work? Is this comfortable given our space? So a lot of the tape is still on the floor. Another thing I did in building the double layer is the upper deck went in first, and it was all the track was put in, all the wiring, all the landscaping, all tested before the bench work, anything else went underneath it, because you had better access and it was much easier to build, and you weren't dropping all this stuff in the bench work and damaging your track and all that. So you really didn't have trains running fully on this till almost all the bench work was done. So you couldn't really enjoy it. So you had to be a little more far-sighted and look at this as a project, like a project manager type of thing, if you want to do this efficiently, in my opinion, anyway. So, and you can see here where the bench work is being built right here long before the bench work beneath it, and the upper deck is all landscaped while we're building the bench work down here, and same thing here. And this was a real headhunter right here when they're coming through that door. And then various landscaping along the way, pink foam insulation, because it seemed easiest to work with given the volume I'm working with. And there's a lot of it, this wedding cake layer stuff and rasping it down. And here where I have these heavy, big bridge scenes, I figured I'm going to pour water in there. And I've seen people that had the magic water or Envirotex, whatever, run off the layout, down the fascia, onto the floor. And the stuff, you can't remove it. It just sticks to everything, and it's pretty much epoxies anything it hits. So built a bathtub here and caulked it in, this whole thing. When you put the fascia on, it is a bathtub. So yes, you're going to build your mountains in here, and you're going to caulk it in further right here, and then you're going to pour water, but it's never going to get out of that as long as you've sealed it with caulking. So that was just building a big bathtub at first, and all the bench work to go with it. And then the embedded helix, talk about a bunch of crazy nonsensical angles and make all this work. You can see how the girder worked off of this, and then we were just fudging this along as we went, because we really had no idea. I just would think about it for a while, and then we'd start building. And so get this helix really is embedded because tracks had to go on both sides of it, on both the lower and upper deck, and yet maintain access to this helix and not cover up anything critical. So you can see the bench work got to be, at least for us, rather complex to go around this type of thing. But this is how we first started laying it out right there. And we were so dedicated. The first time we cut on all these loops out of hickory plywood, it was expensive stuff because I didn't want any voids, because the circular part here is part of the load-bearing structure. So I didn't want those voids you get even in sanded A plywood. You'll get voids. So I got the ridiculously expensive plywood, and you get 2 loops out of each piece of plywood. We were so dedicated one night, my friend was coming over, but we lost power. The power in the neighborhood went out. We fired up the generator in the basement here, outside the basement, and hooked up some auxiliary lights, and we got the saber saw. We cut all 13 loops of that first helix anyway, even with the power out. That's how dedicated we were to keeping on schedule. Here, as the island was growing, you can see how it started to get embedded with the backdrop. Another thing to note with this layout, there's only 4 places that it touches the floor. Everything else is laser leveled on the wall, coming off the wall. There's 2 of these X's holding up the entire island. And then you have the helix, and you have 1 little X under the staging yard. Everything else is off on the wall, coming off the wall, because the floor, although it looks level and all that, it is anything but. There's a huge difference in elevations, and I didn't want people's feet, I want to minimize their feet bumping anything in the floor, keep it as clear as possible so you can scoot around here if we ever do put a skirt in here. So you can see as this was growing out there, and it looks like it's precariously balanced right here, but it's really not. It's really very, very sturdy, so I like to think. And as the island was growing, this whole island right here, this whole upper part of the island that you see where it's not painted yet is one piece, and that's intentional because it's designed to be detached and moved at some point. It is not centered in here on this. So this where the stock port, the port is larger than where Bagby is on the other side, but yet the center of the upper deck is centered on the X right here. So this whole thing is cantilevered off right here. And I wasn't sure with the weight, how that was going to support, but it worked out because each of these 2 decks are separately self-contained decks that are built and placed in there. And you can see them in place here. And each of these decks has their own pickets up here for the backdrop because they can be cut off right here and moved separately. So the whole island is basically 3 pieces that are designed to be moved if necessary. And I say designed to because who knows if it'll actually work until you try to move it. There it is in under construction right there, that's like a couple of years ago, maybe right there. That's all I had for presentation. Are there questions? Because there's a lot of stuff there.
You mentioned we a lot. So you've got a build crew that you're working with. How many people do you have with the build crew, and how were they involved in the input of how to build this thing? Very clever.
Well, thank you. I have my one friend who came over periodically, but 99.5% of everything you see there was built by me alone. I did all the track, all the wiring, all of the fast tracks, all the electronics, all the layer cake scenery. My wife helped with, made some of the trees. She was hand making initially, but we bottle brush trees, but it was too many. We needed thousands. And so my friend sourced that, and he put some of the trees in, and he had some input. So although most of it was built myself with his input, it was built better with his input. And he did give me help with the labor of it. But as far as the design, where it goes and how it's built, that's all me.
Kevin?
Yes.
What's your background? What do you do for income?
I'm a patent attorney now, but I had a couple different engineering careers before that, which probably that's what gave, the ability to do this, I think, is engineering, and not being, as I growing older, I've become a lot less risk averse in some areas. So I'll just jump into something with this, like a project like this. But, I was told by various veteran model railroaders to get trains up and running as quick as possible. But I agree with that, because you can get lost in something like this and just kind of give up because it becomes too overwhelming. But I couldn't do that based on, like Lee was talking about, the way I built it with the top-down approach. You couldn't really get trains running to any significant degree until you got it pretty much all in. COVID helped because all of a sudden I was working at home, and that helped a lot. It saved 4 hours a day of driving, and that helped a lot to move this along.
What kind of an operating process, system, concept have you developed so far with your layout?
Right now, I will probably have various trains come out of staging, locals, and go to different places to switch here, and then they can go back to the main yard or back to staging. Other trains may come out of the main yard. So I haven't fully developed it, but basically it's going to be locals going out to these different places, and they'll originate in the main yard or from staging. Now, meanwhile, you're going to have mainline traffic. Because there's multiple passenger trains and other through freights that I'll have going just to create the traffic on the main line, because it makes it a lot more interesting out there. It takes a lot longer to get from one place to another with all that mainline traffic, because you got to pull over. We had one test session here when this was starting up, and one person got stuck in the hole on a siding for an hour here because of the mainline traffic, which was crazy. But that's just the way it was going in time. We're a little more organized now, but it really can take a long time to get across that, especially when you got a couple of passenger trains and one or two through freights going on here. And the dispatcher is very, very busy. So I, as a train master, operate from the computer the staging yard to send trains in and out, because the dispatcher is way too busy on the panel and on the phone directing trains in the few test sessions we've had.
It sounds like you could support quite a few operators. It looks like you have quite a bit of space available for people to move back and forth to with your layout design.
Well, yeah, it looks that way when you get down there. When I originally was putting this together, I thought maybe 6 people down here, because it's not that big of an area. There's no HVAC down here. You got to open the side doors to the other rooms and turn the fans on, and you get a little stuffy. And I was worried about that, but it seems like the people can be down there. But Chuck Lee said easily 10 people down there. To me, boy, that's a lot going on, and train master to manage. I tried running a train once when people over, and that was a disaster because there was too many questions coming my way, and I lost track of my train and the layout, and it was just a mess. So I won't ever do that again.
I have a question regarding your cart cards.
Oh, the cart cards, I do them all myself off a spreadsheet that I think a lot of people have, that's gone around, that you can print your cart cards. I have on there a picture of each car, because you can't, in scale, you can't read the numbers very well. And it's kind of like Jim Youngkins does it. That was my model, how you have Jim Youngkins. The most minimal amount of information you need to present to get the job done. Like, I don't have the length of the car. I don't have the color, because you can see all that, assuming you're not colorblind. If you are, that might be a challenge. And then I have the number of the car there, and then you have your waybills in the pocket, and that's it. So we printed all those. And until a few weeks ago, I had about 148 freight cars, but that was such a small portion. I couldn't really do any operations on here with that. because I figure you need about 550 to 600 freight cars to really fill this out. So in the last few weeks, I've gone and gotten another 230 freight cars. And each car that comes on there has to have the wheels replace the metal wheels, a resistor put on one axle, so you got block detection working. And then I found out operationally I need to put body-mounted couplers on the ones that don't have it, because if you know the N-scale, most of them come with truck-mounted couplers, and that has presented various problems with derailments and uncoupling. And when I use the body-mounted, it eliminates all of those problems. So in the last couple of weeks, I've acquired 230 cars, done all the wheels, resistors, taken pictures, printed the car cards, and done body-mounted couplers, I think 121 of those so far. So I've been working feverishly to get this operational.
How many hours do you spend on it roughly per day?
I don't know. It varies. Some days maybe 6 hours, but it just depends. Some days after I built that CTC control panel, because that was more of an obsession and like a project, but it was more of an obsession to get that done, the hardware one. And last summer programming it, learning how to program it, because there's no real plan out there, complete plan to do any of that. You got to kind of figure out the logic and all that. After that, I was kind of burned out. I mean, once that CTC panel was up and tested and running, my mind was kind of cooked after that for a couple months. I had to just take a little time off and regroup myself. So, but I don't think you can get one person get something like that done unless you throw yourself at it over in a reasonable amount of time.
Wow.
So that's just my way I do things.
That's impressive.
Thank you. I'm no carpenter either. I mean, I didn't have a table saw, and we just started using the compound miter saw and then routering stuff and all that. You know, I had to learn all that in the 3D CADing and the JMRI and all the electronic stuff. I had to figure it all out. So
yeah, the electronic stuff is what amazes me, is how you develop state-of-art technology to put it into your layout.
Yeah, it's funny that things were moving so fast. Some of the electronics I have aren't even available anymore. So fortunately, I had purchased spares anticipating that, because I figured something like that might happen. Things are getting harder to get. I don't know why. Some companies, they one-man shops go out of business, but sourcing some of this would be more difficult now. You just have to do it differently. Yeah, it's been a lot of fun, and I always welcome visitors. Anybody wants to come over and take a look, I'm almost always here, and would love to come over and chit chat. I had people stop by and want to go over signaling, although I'm not an expert in anything. I'm the first one to tell you that I'm not an expert on signaling or LocoNet or anything else, but I just figure out what I need to know and do it and implement it to get done, to get to where I want to go. I know as much as I need to do that.
Hey, Kevin, can you show the slide of the electronics panel underneath the layout and just walk us through a little bit what some of those components are?
Sure.
And also, did you make those gray panels?
Yeah, I made great panels because I don't show my first one over above the workbench. This is in the bigger room. The other room I did first, but I needed somewhere to put all this stuff, and I wanted it to, I didn't know how much heat it would generate, electronics, so it had to be vented so air could at least circulate through there, so I didn't want it closed up. And I had some spare wood hanging around here and spare fascia material, and I think I had a spare piano hinge too, so I kind of just took everything I had and say, okay, what scraps do I have? Let's see what I can make out of this. And so I made one of these panels. And in the front of the other one, I put the buttons like you see right here for the different power sub-districts, so you can shut them off and maintain them. So right here is the circuit breakers for each of these. Is it PSX? I don't know who makes these things. DCC Specialties, I think, or something like that. So each sub-district has its own breaker. And I tried to lay it out so when I was thinking, okay, what happens when somebody's switching? They're going to run a turnout. They're going to short things out. Okay, so we want to make sure when they do that, nothing else is affected. So they just short out their area they're switching. So that's what I tried to do, and that's happened. People have been over here. You hear because there's an audible alarm. There's a speaker you put on that right there, and you hear the beeping going off all the time as people are doing that. But it's not shutting anything down except where they're working, so it only affects them. So they clear the short. This is a Jackrabbit Quad stationary decoder for four turnouts in the upper deck. It's very large and it only controls 4 turnouts. It's got a lot of capabilities, most of which I don't use, but it controls 4 of them. When I was setting this up, there's a lot of different decoders out there, but this one had to have plugins and talk on LocoNet and give LocoNet feedback. So that narrowed it down to about 3 different decoders I could use at the time. So that's that one. This is RR Circuits TC Mark II, which I also use. You saw them in the dispatcher panel, and what it is an interface between LocoNet and your electronics. That's what it is. And in this case, it's being used to interface with RR Circuits block detection boards right here. So these light up and then also send a LocoNet message when a block is occupied. Okay, and here's some more breakers right here.
Those are not LCC components, is that right?
These are not LCC, and I looked into LCC at the beginning of this, but when I was doing this 6 years ago, things have moved on, and I knew they would. LCC at the time, and I haven't looked into it recently, would only have been good for an accessory bus. Okay, right. So you weren't going to control your locomotives over that at the time. So I thought, well, if I do LCC, there's only one supplier. It's RR Circuits, Dick Bronson, great guy. But I don't want to single source my components like that because bad things can happen. And you can tell in the industry, when you start single sourcing stuff, bad stuff can happen when that single source goes away. And LCC it's a CAN bus. It's like in your car. It's a much more capable and stable bus than the serial bus here, is my understanding. And that's great. And then a lot of his components didn't interface with LocoNet. I wasn't sure how LocoNet and JMRI and LCC all talked. I didn't know. So I went more the standard LocoNet approach, where I was a little more familiar with the components and how it worked. I think LCC is great, but it just wasn't mature enough when I started this, and we were moving really, really fast, so I couldn't let it evolve. I already delayed the start of this layout by 9 months because I couldn't source turnouts, couldn't get them. And that's why I learned to do fast tracks out of necessity. And we'll save a lot of money in the long run. And then down here is your stationary decoders from Team Digital, who's now no longer in business. And I chose their decoder because it had control 8 turnouts, and the form factor was very small, and it plugged into LocoNet. So hands down, best choice for this, because I didn't want to, one of those controls 8 and this controls 4, and this is about twice as large. It takes up real estate. Real estate's valuable in this basement. Down here are your Digitrax SE8C, which is now gone as well. They have a replacement, but controls the signaling. These are signaling decoders, basically assigning addresses to each of your signals and the colors. And of course, that talks over LocoNet. They replaced it with one. These control, I think, 8 control points, and I think their new one only controls 4 control points. You need twice as many of them, but they're about half the size. So, I don't know if it's a loss. And then the phone system, you can buy, and Chuck told me all this. You just buy a PBX, a phone box off of Amazon, and plug your phones into it, and boom, you got a phone system. So that was a no-brainer. And I just rigged up a little shelf in here as an afterthought again, because I didn't plan on a phone system, and got this very inexpensive phone with a big dial and lit so you can see it, and no bells and whistles, very inexpensive. It's, if somebody drops it, it's not a loss. And I got some spares, and so very easy to use. These are power supplies for the in the big room of the layout for the LED strips that are lighting up the main deck. So those LED strips are on the bottom of the upper deck. Originally, I had one power supply because you got to do the calculations for the current and the voltage. I went to 24 volts because I could get longer runs than I could under the 12 volt, and I got brighter lights and longer runs. I originally had one power supply, again, for real estate reasons, but it had an exhaust fan. I thought, well, I can live with that. Well, after a while, no, I couldn't. It was just too much extra noise. I didn't want to deal with it. So I ended up splitting it up into 2 power supplies with no exhaust cooling fan on it. And then here is your Digitrax 2 boosters in 1, whatever that's called, for the power districts right there. And then there's a big power supply for that hanging out here as well. And then there's tons of wiring around it.
Hey, Kevin, how many boosters do you have?
I have 1 command station. Then I have the 2 boosters in here. So you have you have 3 power districts. Out of the power districts, you have 13 sub-districts distributed amongst those. I think each of these boosters has 4 sub-districts right here. You can see it, and the main command station has 5 sub-districts. They're all isolated. You can isolate each of them right here with a switch. And it pays off. I mean, because people are always shorting or something will derail, something like that happens. And isolating these in as many power districts as you can stand, it sure makes operations a lot better than taking down large swaths of the layout when someone runs a turnout. And then if you're working on it too, because you come out here and you're working on trying to figure something out and the layout's powered up and you don't want to work on that anything powered up, you can just shut that area down and work on the track, else something, and then turn it back on and test it. So it was a lot of build and test. Everything on here, my philosophy is build, little bit test, build, test, build, test. And my friend would get kind of irritated how much I would do that. I said, well, you just can't build large amounts of stuff and then turn around and hope it works. It's much easier to test it as you go along, even though it takes longer.
On your Helix, you use the Cato track, the double track?
Yes. I saw that at somebody's layout, Jerry something in Portland. I saw this at his layout. He did the same thing. Wow, that's a much easier way to build that. My experience has borne that out because this was originally just before I had my epiphany and made this twice around each deck. This was just winding all the way up and down, and it had one track shot off right here. But the whole Helix itself was the double track Kato stuff here. But when you break it up like this, I had to have a section right here that was just single track. Now, Kato didn't have the right radius in single track for me to do that. You know, it's super elevated, then it has to have a transition piece, then it comes off. It's not super elevated here because I wasn't doing that in scale, and goes back on and connects around here. Well, this was so much easier to build because you're slapping these tracks on here, gluing these little foam core pieces on and let it dry for a half hour. Then you can put your next layer on and you can just keep building fast. Okay. You start putting this track in, takes a lot longer. It's a lot more problematic. And boy, you better get it right because this is hard to work on once the track is in. And if you don't get your curves just right here, you know, some abrupt curve changes, or it's not level perfectly because you're bending the track, you're going around curves, it can pop up when you're gluing it down if you don't have it weighted until the glue dries. And even if it does, it can still pop up and create uneven portions in the track, and you get derailment, especially if you have truck mounted couplers. You can especially get derailments in those transitions, or if the track is not even an in scale anyway. So I'm very glad I'm using the Kato. Unfortunately, you've only got the one radius you're doing, which seems kind of tight, but it works. It works. And I didn't want to make it any larger because this thing just takes up a bunch of room. I never wanted to do helixes in the first place, never did, but given the space I had, I couldn't get the elevation difference I need. The whole main line would be this constant grade. And, if something happened, a train would just cut loose behind you, it'd be gone. I mean,
what is the radius of those pieces?
I think, what is it? I think the wood here is cut at a 20-inch radius. It's 4 inches wide. One is 16 and the outer is 20. So the Kato's falling right in between there. Different radiuses for the two of them.
Yeah.
By about an inch. So what is it, 17, 18 inch, something like that? Which isn't bad for in scale. I have tighter radiuses on the layout than I have in some places, unfortunately, because I had to, than I have in the Helix. So this isn't a constraining factor as far as radius of curvature. There's other places that are worse, you'd call it. But, if something gets loose in this Helix, if you don't catch it right away, it's gone. And we had that. So unfortunately, most of the time, these operate pretty well. I'm still acquiring locomotives. Like I have about 40 locomotives. And of course, when I get a locomotive, oftentimes they're used. They're mostly Kato, and I tear them completely apart, clean, lubricate, often have to replace the wheels, replace the couplers, and put them back together, and then run them and test them and run them and test them.
Kevin, are you using Z-scale couplers for your
microtrains couplers?
Microtrains, okay.
Yeah, and I just I just learned the last week and a half of the body mount, changing all those out, and very, very laborious process, not fun. I wish they came body mounted. It just operates so much better. The truck mounted just give me so much trouble, and not just backing long trains, which I haven't done a lot of that yet, but just pulling over the Helix. I was getting periodic derailments in here between certain engine and car combinations. And you look at the track, you got your optimizer, you can't find any problem with the track in places, but it's just some little perturbation in the track, some little thing that, slight change in radius of curvature, it'll pull the car off behind the engine. You've got to have the body mounted couplers, but it's time consuming and expensive to do that. So a lot of people aren't going to do that, and I understand it. But if you don't want your train cutting loose in the Helix, and you better do it. back here on the another subject, the dispatcher panel was created on the JMRI software, which you guys are familiar with, most of you. That's the free train control software out there that does a lot. You can program locomotives. You can do switch list on it. You can do all kinds of stuff. But you can also create panels on the computer for controlling your layout. I didn't know anything about JMRI, and it's kind of funky to use. It's got a 90s type of graphic interface. It's not really up to date in that respect, but it's free and it works. So I can't give it too bad of a time. But I didn't just go from zero to building a USNS CTC panel on JMRI, not at all. At first, I started out trying to figure out what JMRI is and how it works, and I would use it to test my turnouts, block control, and signaling addressing on LocoNet with JMRI. Just create things and mess around with a scrappy panel on there to figure out, okay, how does this work? How is JMRI using these addresses, and how do you make buttons and lights work on here? And I created numerous layout panels on there that were not the one you see today, just to test it out and see if it worked and get the knowledge of how to do JMRI. Then when it came time to build this monster, that was yet another level of learning how to function within JMRI. So if you're going to build a hardware USNS panel like it was done here, you and JMRI are going to have to become best friends. You're going to have to know it cold, in my opinion. Now, I've seen people create the hardware. The other way is using, I think, Bruce Chubb's CMRI boards, which are another way to interface between electronics and LocoNet. And people build panels at clubs mostly that I've seen build panels that way. But you have tons of wire coming out of the panel and network cables, just wire. As Chuck pointed out, and it's true with this panel, all you have is a power connection and a LocoNet connection out of the panel. That's it. So you can move your panel around. That's what Chuck was doing at his place for a while. That's it. You don't have all this wire coming out because it's all been reduced to electronics that are on boards within the panel itself. And you're interfacing with the LocoNet in there as well. So it's a very clean design. And Chuck, he's genius for coming up with it. In my opinion, it really works.
So with that process of the LocoNet bus, you're pretty much locked into using a Digitrax system. Is that right?
Well, you're locked into using a simple serial bus. So if it's a 6-wire bus, then yes, whatever JMRI works with, because I couldn't use LCC. I couldn't convert it to that necessarily. I would have to swap out these right here that interface with that. If I swap those out for LCC versions of this, which he may have something like that, then you could use this on LCC. You'd have to reprogram the addresses because each light, each button has a corresponding address. This panel is just an extension of what you see in the computer screen. It's basically a hardware interface to the computer. So this whole thing is created on the computer first, the buttons, the lights, the switches, and you're operating it on the computer screen. That's what you're doing at first. That's what we did. This just creates a hardware version of that. So each of these lights and buttons and levers all have their own address. And not only on JMRI are you programming what that address is, you have to program these, and those addresses have to correspond. So if it's a light on the JMRI computer, it has to go to the same address on here, and then that wire has to come out onto this board and go to that light or switch. So it's a big, huge bookkeeping exercise. Huge. Does that make sense?
Yeah, it does. Although a bit overwhelming for
it is. It honestly is overwhelming. You can ask my friend. I had to be a fanatic about this to get this going, and that's just me. Now, I think a club layout that has more people with varying skill levels might take it on in a more leisurely fashion than I did. I mean, if you came over last spring, I think you did, Lee, when I was in the middle of building this, or I had to source the parts, they were laying around. I think you're over here. I mean,
that's right.
If you got in my way, you might lose a finger or something. I mean, it was that harried of a building thing. So it was really dedicated.
But also, I see that you're using essentially modules over and over and over. So once you get the basic scheme figured out, there's a lot of just grunt work to put it together.
Absolutely. The whole thing is you're putting it together. Once you do the JMRI and you create it on the screen there, then you're building this huge spreadsheet so you can program these modules here, because I think each of these boxes here has 64 different lines you can program. So each line can control a button, control a light, like that. Okay. Well, you got to get all those addresses correctly, and you got to program these. So you put a spreadsheet so I can say this module, these 64 ones are going to be these addresses at these points. Okay. And then you got to know how the wire comes out, which side's up, and then how it's going to interface with your board and what that's going to connect to. So Chuck was nice enough to give me the Gerber files for these boards so I could go into them and see how he made them and trace all the wires where they go. Because you're soldering on each of these boards, you're soldering switches right here, your LEDs, you have resistors, you have connectors. Every line, every address has to work or this thing doesn't work. Yeah, and then some of these parts, like this one right here, this is a 60-degree lever switch. They're basically almost don't make that anymore. And I found that Chuck put me on it. It was discontinued, and they only had 400 left in stock. I bought 200 of them because I never, if I do this in the future, ever want to try to source that component again. Now, the one that operates the signals, the 3-position 60-degree one, is readily available. But you got lights because you're going to use 10 millimeter. You're going to use 8 millimeter. And then you've got to size the resistors to get the light brightness you want. So you have to, I had to bench test all these. You got 4 different colored lights. You have green, red, yellow, white, and blue. Some of them can use the same resistor value for the brightness that you want. Some don't. You've got to figure out what that is. So you got to fire this up on the bench, lighting up a light with a resistor. And was this too bright? Is it too dim? I have to change my resistor value. And then you got to keep all those straight when you're soldering all these resistors on the board, which one's going to which light. And then I had to create a jig right here so I could get these lights at the correct elevation above the board. So when they went in here, they would be sticking out properly in the bezel. So if when you solder those on the board, you got to put them at the right elevation right here with a little bezel mounting thing behind it. So I 3D printed that. So since I CAD'd this whole thing, I just took this and 3D printed it with all these holes right here, which you have to figure out what size hole. Because, Chuck gave me this board, but sizing what the holes are and what the dimensions between them are, you got to figure all that out. Then you got to CAD it and have your steel drilled for that. And you got to get it right. You start doing that. If you screw it up, it can get expensive really fast.
Really fast and time consuming to
very
correct it.
So, I had to steel print it, and then I take this right here and I mount it. Does everything mount into the steel? Okay, well, we can do the artwork then, because the artwork was the most expensive part of this, probably. And then finding someone to do it, because I'm a hobbyist. This is a small job. So I had to find, there's a lot of places out there that bend metal, cut metal, laser cut, etch, anodize, all that stuff. I had to go through 3 different shops finally, and I found one in Mukilteo that would actually talk to me about this and do it. Because I had to work with a project manager there, going back and forth to get what I wanted, to make sure I was getting what I wanted. And I had to drive to multiple trips to Mukilteo from Auburn to talk to them and pick this up. And it was an iterative process. But fortunately, everything was made right the first time. And hats off to them for doing it.
Just amazing. It's great you had a vision and you've stuck to it. Now you're really getting to the finish line of a product that you should be proud of.
Well, thank you. I'm kind of a lone wolf working in the dark here. I don't get out that much. And so I just was pursuing a hobby.
Well, and I think as you get toward operations, you've got a whole cadre of new people who'd be interested to operate on your layout once you get to that point.
Yes, I love having people over, love talking about layout, would love operating it. I think it'll be a lot of fun once it's fully up. Mostly I need to get the waybill thing now. That's where we're headed. I know how to make them. I don't know what you need to do, but I don't know how many industries, and there's 220 some slots and industries around here. So I got to figure out how all that's going to connect and interconnect and, a 4-sided waybill. And I know how it all works. It's just getting it all connected in here to flow. And that's going to be an iterative process too. So that's why I'm only got 368 freight cars only, but I need probably 600 to really get the yard working at full capacity and everything running at full. But we're going to start with this many and see how it goes.
Well, I think we've gone a little bit beyond the hour of 11. So all this information is great. I'm sure the folks on the call have really enjoyed this. We would like to extend a great big thank you to Kevin for making this presentation today. It was fantastic, Kevin.
Okay, good. Thanks.